Welcome to the video. Here's the probability question we're looking at. Suppose that 20% of people own dogs. If you pick two people at random, what is the probability that they both own a dog? So a couple things we want to notice here. The word random is used to describe how we pick the two people, so that's going to allow us to assume that they're independent picks. The probability that we picked the first person, or whether or not the first person has a dog, gives us no information about whether or not the second person picks a dog. So we would use like perhaps a random number generator to choose individuals from a population to ask this question to. Notice that if we were asking people and we went to the park, well, the probability that the first person has a dog, or that the answer the first person gives us about having a dog might tell us something about whether the second person has a dog too, depending on the location we picked. Maybe the location we picked was a park that doesn't allow dogs. So it'll be less likely that either of those people had dogs. But because we know we're picking them at random, we're going to be able to assume that the answer the first person gives us has no impact at all. Oops, sorry, that should be a straight line on whether or not the second person has a dog. So we're picking at random. So we could think about events here. We could say let event A equal the first person has a dog. And we could say let event B be that the second person has a dog. And notice the question tells us the probability of event A, the probability that the first person has a dog is 0.20, and the probability of event B, that the second person has a dog, is also 0.20. So now if we use statistical notation to describe the event we're looking at, the probability we're looking at, we want the probability that they both own a dog. So that's really saying A happens, the first person has a dog, and B happens. For both events to happen, we're looking at an AND situation. So we're looking for the probability of A and B. And because we know A and B are independent, we can use that multiplication rule for independence events. We can say the probability of A and B is going to be the probability of A times the probability of B. And note, we're only allowed to do that because A and B are independent. No, because, oh, it doesn't want to put those letters down. Let's try again. Because A and B are independent. So to calculate our answer there, we could say the probability that both own dogs will be the probability of A, that the first person owns a dog, times the probability of B, that the second person owns a dog. When we do that calculation out, 0.2 times 0.2, we get 0.04. And notice they don't indicate it needs to be a percentage, so we can report our answer just as a decimal there. 0.04, which is pretty interesting to note. If 20% of people in the whole population own a dog, well, that seems, that's not that unusual. But the probability of picking two at random that own dogs goes down to 0.04. So there's a 4% chance that if you pick someone at random and then someone else at random, both of them would say, yes, I have a dog.